also your own personal growth in your SolidWorks design. Remember, these things cut across. Yeah, for example, you can be 6 months into SolidWorks, but you can also solve complex stuff, and that's what you're going to witness here. So feel free, and also as we'll be learning along, keep your questions so that we'll ask Yusuf at the end of it. He's going to delve into each and every questions we'll ask. The chats are also open. You'll ask your questions over there. So in the meantime, the Nairobi City SWUG would love to welcome you for the session right now. And I'd love to welcome Yusuf to just start the session and to take over. So thanks so much, and you're welcome, Yusuf. You can share your screen and take over.
Thanks, Jonathan, for this introduction. It is more than I have actually, but thank you. So we'll get started now. Is the screen good for everyone? Okay.
Yes, I can see your screen on my end.
Okay. So before we get started into the technical stuff in the exam or the requirements, we have to talk first about what is exactly SolidWorks certification program is, and where exactly is the position of CSWE among all the certifications that SolidWorks provide. So if we search SolidWorks certification program on Google, we'll find multiple categories in design and engineering, manufacturing, life cycle, simulation, and marketing. So SolidWorks provides a lot of certifications in each of these categories. So for example, in design and engineering category, we have CSWA, CSWP, sheet metal, which is professional advanced, the emitted advanced, but it is a professional certification, along with weldment, surfacing, drawing tools, and mold making. So all of these certifications are provided by SolidWorks, and CSWE, which is the certified SolidWorks expert, is the highest certification among them. And if we see the exam information, we'll see that SolidWorks define this uh, certificate by a definition, which is a CSWE is well-rounded in their knowledge of all areas of SolidWorks software, and a CSWE is able to solve practically any modeling problem given to them. So CSWE is really an expert in the software, and the one who possesses this certification has a knowledge which is normally the one to go to SolidWorks user among their colleagues. So the exam prerequisites are actually 5 exams, different 5 exams to have the possibility to open the exam for you. The first one is successfully passing CSWP exam, which is a separate exam, professional exam, and 4 of the CSWP advanced topics, which any 4 of these 5: sheet metal, weldments, surfacing, mold tools, and drawing tools. If you pass CSWP and 4 of these advanced, then you have the opportunity to purchase or have CSWE, and you have to as well pass it to get the certification. So the exam is 4 hours long, and it is actually the longest of all certifications. It is an intense exam to be honest, and the minimum passing grade is 80%. So it covers a lot of topics actually, lofts, sweeps, and all of these. We'll talk in this session. I will not take all of these requirements. I will just select a couple or multiple of them, around 13 questions of them, which I find that will be beneficial. I took my certification or the exam in 15th of September, which is Yes, 5 months ago. So I have a fresh memory of the exam, and I hope that this session will be beneficial to everyone who's intending to go to this exam. So let's get started. I prepared actually a PDF that will be solving from it. So let's open SolidWorks, create part, and see the first question that we have.
Mhm.
So it is about belts and chains. If we see the page that we just left, belts and chains are one of the main requirements for the exam, and it will essentially have a question or multiple ones in the exam. So let's get started. We have a sketch here that we will go to SolidWorks and draw the belt out of this dimensions. So let's get sketch, 4 circles, 50, 35. Position of the circles is not important now. After we make every one or each one of these circles a block, then we will define its position. So right click, make a block, and yes. It is important to make each one of the circle a single block, not to make this and this block. This will restrict the relative movement between them. So this is wrong. We'll delete it and make this circle block and make this and this too. So let's define the position now and make this in the center line or the center origin point. Uh, T, T, C. So each step of defining the dimension is crucial. If you don't do that, then the question will be wrong or the answer will be wrong. If anything, yes, 100. Mm, I think all of them are fully defined. No, they are fully defined, but they are rotating about the x-axis. So now let's give uh, uh, add the belt and chain. Here we see that the thickness is 15 millimeters. So from uh, tools, sketch entities, belt and chain, or you can search it, or you can have a toolbar that will say you can select the command from it. Either one is fine. So now we have to select the pulleys, and the arrangement of each pulley is crucial to have the shape of the belt. So this is the shape. Yes, it is, and we have to give a belt thickness of 15. So this is the first question, and all dimensions are good. Now we have to get the belt length, which is written here, 640.24 millimeters. Basically, this is a question could be like that. It is not hard, but you have to know the basics or uh, the topic of belt and chains and blocks. So this is could be one of the questions. The second question, before we get into the second question, I have to emphasize something that equations is important. If anyone intending to go to CSWE, he probably passed CSWP and CSWE also, so he knows equations and SolidWorks procedure in all of the exams. We have to enter some kind of equation angle or dimension, and we will use it a lot to modify some parts to make a part easily modifiable. So let's see, let's make it 80 degrees. See this question. In this question, uh, I'm the one who made it, so it is not perfect and it doesn't have the best layout like the exam. But I will tell you the idea behind it. If we have this angle, or let's make this block, let's modify it. We have a circle here. The angle is 45. Very good. So there is a command in edit belt which is engage belt. This one, let's make this to be clear. Make a circle here, doesn't matter where. When we rotate one pulley, each of the pulleys rotate as well. So when this pulley rotates like 30 degrees angle, this should rotate also an angle, a certain angle. We don't know what. It is a ratio between the diameter of the pulleys, but it's not, this is not the case now. We will just determine the angle as the exam said, like this will be A. And we will add a circle in the second pulley and we'll determine he will want he wants in the exam the angle between the pulley or the angle of rotation of this pulley uh, that happens because of the rotation of that one. So using equations is important to know in all of the exams. Let's modify this. And this is the angle. It is driven because the belt is already fully defined. So this might be the answer of that question. So this is about belts. You have to uh, draw the diameters, to draw the pulleys and add the dimensions and relations. And the belt thickness that he tells you in the question, you have to add it. And if he tells you to engage or not engage the belt, and also the orientation of each pulley is important to solve this problem correctly. And this number is the belt length, which is probably he will be asking for. So this is about first or second questions. He could actually give you a question in which you will draw the pulley or this system, and two questions to modify it using the equations. Like this will be 80, now it will be 60. And to see the new number or the new angle of B, he will be he will want to know the angle B, and the angle B will depend on the angle A. So that could be multiple questions actually. Very good. So this is the first question. Let's save it. Whenever you solve whenever you solve a problem on an exam, save it so you can revise it later, or you want to revise your exam afterwards. So question one. Anything. Making task down. So this is question one or topic one. It is one topic, but he could give you three questions about the same topic. So the second question is actually 3D sketching, which is I count it is hard if you don't know the optimum way to solve it. So let's see. Let's see the sketch. So we have a 3D sketch here, the isometric view. And here top view and side and the front. From where we should get started. So he gives you the dimensions of the back of the sketch, the one who is on the ground. So we can start from it. I will start by the the easier way to solve. Then I'll go to the not so popular way to solve it. Mm. Okay, 61, 16. So if we notice here, there is in all of the edges, there is an angle. So this indicates for a draft. And the word draft is the hint for this question that will that you can solve this question in 10 minutes or 2 minutes if you know the that you can use draft. So let's continue the sketch. 65 and 60. So this is the base sketch of the 3D sketch. Now we have to go to 3D sketch and add all the lines and angles uh, to get the shape of it. But this is takes time. It is time intensive. We have to the top plane is not known for us. The dimensions of it is not known. So we have to know it by uh, drawing each line of this, and then we can draw from point to point till we get the shape. But this will take a lot of time and is not the best way to do this. Uh, in this view, we have 70 degrees draft, and the same one is 70, so it is 70 degrees draft in all directions. This one 70, this one also. This one is 80, which is this. I'll draw it because it may not be clear to everyone. This is the base sketch. I'll just do a bus extrude with 80 height, 80 meters. So this is the basic shape. We have to add drafts in multiple faces. So this face is inward, this face is inward also, and this face is inward. And this face is outward draft. Feature, draft, first method, neutral plane, and the draft angle, it is not 70, it will be 90 minus 70. So it is the angle that completes the 90. So it will be 20. This face and that, and will the draft direction will be reverse. Yes, yes, this is it. So if we see, it is perhaps some kind of, it does look like this shape. This is 70 degree if we look from there. Angle in this face, I wanna convert that line and that line and see the angle. Yes, it is 70. So if we projected the lines or the draft lines on a face perpendicular, which is in this case the view itself, the elevation view, it will give us 70. So this is what draft makes. So these are the faces that inward draft has inward draft, and the other face have outward draft. This only face, check, yes, and this straight 80, it was 80 degrees, so 90 minus 80, 10. And the direction of the neutral plane is the one in the back. And the faces the draft is this, and the direction will be like this, which will make the draft outward. So this should be our shape. We have to check. Let's see these angles, this one, convert, see, it is 70, this one is 70, we wanna see that one. It is 80. Yeah, it is dreading. So now we checked in a plane perpendicular, or a plane that is equal to the view to this view. The dimensions are correct. So the draft way is good. If you try to draw this in a 3D sketch, it will take a lot of time, because in 3D sketch, let's see, I'll just I'll not draw it completely, I'll just make an example. Another one. Z. Yes. Just fix those. If I draw a line in the 3D space, if you want to define it or fully define it, you have to give it a length, absolute length, and two angles. An angle between the first one, an angle between the second line. So if you define the line, each line in this part, two angles and one dimensions, it will take a lot of time and is not accurate like the way of the draft. So to define only a single line, you have to do three dimensions. So it is not the most accurate way. Now we have the shape. We want lines. We want only lines. So the lines that represents the question is the edges of this part. So we want to select all the edges and delete the body. How we can do that? First, we'll open a 3D sketch and we want to select each edge. First, second, third, and so on. But this is actually a time-intensive way. There is another way by using filters. You can right-click, toolbars, selection filter, and put it in any place. There is a filter for edges. You can select selection box on all on the part. He will select only the edges. But there is a problem. It will not select the edges that is not shown. So we have to select it again. Or we can just select all or Control A. It will select all the edges in the part. After we selected, we can convert these edges and exit the sketch and exit the filter also. So now we've converted all the segments or the edges of the part to a 3D sketch. Now we want to delete the part from direct editing, delete body, delete, and here we have the shape of the part. And we have validated that this line is, or these lines or these methods are good by checking the angles. So now what does he want? Oh, the question wants the length of all the line segments. I didn't write it here. Oh, it needs some modification. This PDF needs some modifications actually. The question, he wants all the length of all the line segments. How we can do that? Entering the 3D sketch, and we can Control A, measure, and here it is, the total length of all the edges. From evaluate, measure. Oh, I have a keyboard shortcut so I can. So this is the total length of all the line segments, 2225. So this is the answer of this question. So the tricky part of this question is doing it by adding drafts, then converting the edges, then deleting the body, and measuring the length of all line segments. This is one of the tricky questions. So this is a good idea for a question. Let's see another one. we can add a weldment to the line segments, and he wants us to check the mass of all segments. And there is a cross section, which is a hollow circle or hollow pipe, 20 diameter.
Hi, Yusuf. Apologies. Somebody is asking if you can repeat on deleting the bodies. If you can kindly repeat that.
Is
I've
that
seen some of
question
the
in
chats.
the comments?
Yeah.
I can see the comments actually, guys. So anyone who wants to ask something, raise your hand or open your microphone because I can see it. Or thanks, Charleston, for noticing that. Repeat on the deleting bodies and the other one. Mm. So the command body key slash delete or keep bodies is one of the commands from direct editing. Direct editing is is the tab that has a lot of uh, modifying specialized tool. So we can move face or move a body or delete a face or so on. One of the commands is that we can delete the body itself without breaking the relations it has. So it is different from, yes, it is different from, let's selecting the body or clicking on the body and press delete. So when I did this, all the relations and the dimensions that it was related to the part of deleted is omitted. It is not, it is gone now. So the command delete the body, it deletes the body, but with keeping all the relations it has. So when I delete it, press delete key, the line segments gone. But if I use delete body, the line segments I had is still here. So all the relations are still good. That's it. Uh, I hope this is good. Okay, let's go for the second question. Adding weldments. So in this question, he wants us to measure the mass of the part or the mass of all segments and adding a weldment or structural member. The structural member, he did define it by this cross section. It is a hollow circle or a pipe, 20 diameter, measure, and the inner diameter is 12. So we have to know how to make a sketch that will be that we can use it as a structural member. If anyone who passed the CSWE weldments, he will know how to do this. But we will redo it. 20 and the other one is 12. And we can add insertion points from there to there. Press enter to do the same command. Now we have 5 insertion points. Insertion points, we will need it when we select the structural member. So the line segment will intersect the profile in one of these 5 points. This one, or one of the 4, or the center. So this is a defined sketch. This is the sketch he wants. So press on the sketch, file, save it as a extension of library feature. Where is it? No, library feature part. And you have to save it in the path of the design library or the path of the sketches of the weldments. You can get it from file locations. Yeah, file locations and weldment profile, weldment profiles, and you see the path it has. There, this path is the ordinary one that was set by SolidWorks itself. So you can save it in this, or I did customize a path for myself. Uh, in either one is fine. If you save a part in either of the paths, it will save automatically in the structure member profiles. So let's get back, file, save, library feature. It is hard to find. Hmm. Then I will save it. Weldment profile, custom profile, metric. You have this arrangement of folders. You have to do it. So Weldment profile, then custom profile or any name, and this custom profile has another folder in it, and you put all the files in this folder. I will name it exp2. Very good. So it is saved now. The extension is renamed, and the sketch has an L sign on. That means it is a library feature sketch, and also icon here indicates library feature. So let's close it, Control W, and add the structural member, custom profile, metric. It is already used, metric, exp2, and let's use it as it as it is indicated here. From all line segments, and this is good. We have to add a material. You can right click, edit material, or you have a keyboard extension. And the material it has is alloy 1060. Now we have to measure. We have to measure the mass of the part. We can from evaluate mass properties, sorry. But we have to check this number because there is some kind of a glitch in weldments. You have to select all the bodies, then measure, then have its mass. So 437. Oh, that's correct. But in some cases, there is a glitch that the numbers, the two numbers, is not the same. So you have first to check you've selected all the bodies. Either from there, Control, Shift, click, as properties, and take the number 437, or from cut list. No, you have to select each one from the cut list and so on. It will give you the same answer. So this is the answer of this question. The second one is he wants to add all the segments, and he tells us that there is three corners that have special treatment. They are all mitered equally between the segments. So in each corner there is three segments. Each corner of the three is mitered equally across the three pipes or the three segments. And we use the same profile. We can add a new structural member, or we can continue on the same structural member, but it's easier, much easier to control the corners if we are working on the same feature. It is accessible though if we made a second feature, but it is easier to control it on the same feature. So we'll make a new group, select the lines. There is two conditions to in a group. The group must have a continuous lines, or it must have parallel lines to have in one group. So group 3, I can select another one because they are neither continuous or parallel. So I'll make a new group for each segment of this. Not all of them. 4 isn't. mm, And this, only this. So these are the line segments. So he wants to, but I didn't control the corner. This one, and this one. So we'll edit the feature again and see the corners. Oh, no, it is my fault. It is my fault. The group is selected is wrong. This one, this one, this one, the back one. Yes, this is the correct segments. Now we have to edit it, the corner treatment. So to edit the corner treatment or make it equally mitered, we can click on each joint or specify the corner treatment of each joint by making the trim order equal. Either this one, trim order 1 and 1, 2 or 2, you have to make it equal. So this is equal. This one is equal. We'll make it 1 and 1. And this one is also 1. So check yes. Now we can see that all of them are mitered equally. Like this. This isn't mitered equally, but this is. This is also. So what is the mass of all segments? Now we can measure the mass. 990. I have to check that. It is the same number, 990 grams. So this is the answer of the. It is not the ninth, of the fifth question. So these are the questions for 3D sketch and weldments. It is a good example. And yes, the material we've added 1060. Very good. So this is another question. Let's see another one, which is modeling a spring. So modeling a spring has a lot of ways actually. We can add a circle of a certain diameter, and from this circle we can add a helix by a certain height or pitch. By this way we can make a spring. But in this case we can make that profile. It is not accessible in this easy way. We can actually do some modifications like make a taper of a certain angle. Oh, that's too much. Oh, like that. We can make a taper, but it is not also it will not lead us to this shape of the spring. So we certainly need to figure out a new way to make it. So let's see. The spring diameter is 10 millimeters, and he gives us the profile that the spring is constrained to. So this way is called intersection curves. We can make the curve of this spring by an intersection of two surfaces. Let's see. The first one will make surfaces. Will make surfaces. Yes. Will not make it by a solid bodies. We'll make it by surface bodies. First surface is a revolve of this line around the center line. And the second surface is uh, represents the pitch of the spring. So let's see. Here's the center line. Here's wait, this one is already defined. No, 150. These two are horizontal. Yeah, it is overdefined. And the radius is 40. The 160, 100. Yes, it is fully defined now. Let's check the dimensions again. It is correct. So this is the first surface we have. We will do a revolve surface. Very good. So the second surface we need to get the shape or to get the curve of the spring is something that has a pitch that represents the spring. So let's see. We can make a line and another one. Very good. So this is pretty counterintuitive, but I'll make a sweep out of this in this path with a twist angle. We can specify the twist angle by degrees or revolutions or radians. In this case, we don't have the twist angle, but we have the revolutions. We'll just count how many revolutions are there. First, second, 2, 3, 4, 5, 6, 7, 8. So 8 revolutions. Oh, very good. So uh, we've made the sweep or the pitch surface, and we made the shape that constrains the spring. Now all we want is the intersection between them. Now we can get it. Let's open also a 3D sketch. There is a command called intersection curve. We can search on it, intersection curve, and see where is it. It is under convert entities. It is under convert entities. Oh, I've made a single icon of it, an intersection curve, the first body or the first surface and the second surface. I have to check all of this. And here it is, the intersection curve. Now I don't need these. I can either delete it or just hide it. So this is the curve, the spring curve. All I want now is adding the profile or the circle, 10 millimeters in diameter. Make a sweep. This is called shortcut by pressing the S key, and you can add all the commands you want from shortcut bars. Just drag and drop and so on. So let's add a sweep, and we didn't actually draw the profile, but it is okay in this case because there is a single command or a separate command for circular profiles. All I want is adding the diameter. Very good. I added diameter and choose the path, and we are all good now. So the material 1020, apply material, and we have to measure. So this is the correct answer. So this is one of the hardest way actually to model spring. It is good for intricate shapes that you can do by helix or either a tapered helix and so on. You could make it more complicated by doing a composite curve. Let's leave this for now. By making a composite curve. So you sketch on this and add, let's see, quick example. XY plane, one XZ plane, and add a curve, another one, Gauss tangent, and make another one in XY direction, XY plane. Very good. And these two are tangent. Very good. So this is a separate curve. It is a composite. Let's see if the sweep will do it. Uh, mm, 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 mm. Hmm. So what was the problem? Okay, so we can make a composite curve by adding more curves to the part or to the sketch. If it is a sketch, then it is not composite, but there is a single command of composite curves that will combine all the curves together. But in this case, it is not composite. So this is one way to do it. Let's get back. Very good. So this is our part. So the next one is sheet metal. But the problem here, let's open the part, save, uh, that the sheet metal is not defined as sheet metal. It is an imported part. It is an STL file or step file, either way. So we have to make changes to so that SolidWorks comprehends that this part is sheet metal, and this is easily done by the command convert to sheet metal. First, we have to select the fixed face, which is the base flange if you compare it to the commands we have, and the bend edges we have to select it manually, or we can automatically select it by pressing collect all bends, then pressing OK. Now we have the part defined as a sheet metal part. We know that because the SolidWorks now can do a flatten to the part, and we can have the flatten length he wants in the question X. Mm, oh. So the answer is 288. You can measure it from evaluate measure and click on this, or you can just from cut list, the sheet icon properties, the length or the width is 288. So let's unflatten that. Let's see the second question. So all the trick in this part, we have to, oh, there's an important thing I forgot, is we have to define a key factor. In the question, it is 0.4. In the question or in the exam, it will tell you, the exam will tell you to put a key factor of a certain number. And we forgot also to add the material, which is 1020. And this is the correct mass. So this is the first question. The second one, apply modifications to the part, then determine what is part center of mass. So if we see there, let's see both views. He added slots here or cuts in the bend, and these slots or these cuts are reduced to 2, so these one are deleted, and also the width of the cut is reduced. So there is 3 modifications actually. This could be 2 questions, not 1 question, uh, but we will solve it in a 1 question. So let's start by modifying these slots, deleting and modifying the width. How we can delete this? Let's see. Direct editing. We have a command called delete face. So let's select the inner faces. 1, 2, 3. This is the manual way. There is a command called select tangency, and delete. Can flatten to check if there is errors. There is not. And we can also modify the cuts. The problem here is that there isn't a feature tree manager coming from this pod. This is a step file, so it doesn't have a feature tree manager. So we can't go into the feature and edit the feature and reduce the width. So in this case, direct editing commands have a great help. So let's see move face command. Move face have 3 options, either offset, translate, or rotate. In this case, offset will do the way, will do the job. Select tangency, and 4 millimeters the width. What was the old width? 4 12, so it was reduced by 8. Select tangency, so we'll reduce it by 8. Let's see, there is a preview, flip direction, half of 8, because he uh, reducing 4 millimeters from there, 4 millimeters from there, combined they are 8 millimeters. So let's check the width again. Yes, it is 4 millimeters. So this is the second modification. We've deleted and modified the slots here. Now we want to add a new slots. Rectangle 20 by 10. Let's see how we can add a cut in the bend. There is not a normal plane or a suitable plane that we can cut. So we have to unfold the shape. So sheet metal, unfold this face, collect all bends. Now we have a flatten shape, but we are not in the flatten command. This is what unfold does. So let's sketch 5 rectangles, 20 by 10. And this rectangle It is in the center of the bend. The center of it is on the center of the bend, or in the bend line. So let's get the center of this and make it vertical. Very good. Still this dimension 30. Now it is fully defined. Now we just need to add the linear pattern, 5 instances and 30 millimeters from there. Uh, Linear pattern. The x direction isn't for us, so we'll modify it. This line, entity pattern is this rectangle. We can select each line individually, or if we have the shaded contour, we can select the whole area by just pressing in between. So 5, and I will not fix the dimension X spacing because I will define it from the other edge. So this is 30. Now this is fully defined sketch. We will cut, and we can link the thickness. Now after uh, we've cut the model, we will fold again. This face is fixed, and we will collect all bends again. And to see if there is an issue, we'll flatten. There is no error, so this is the correct part. So we have to measure the mass, and this is the correct answer. So this question will be easy to solve if you know the direct editing commands like delete face and move face. It will be much faster uh, than any other method. So this is the eighth part. If anyone was following chess, you will know that meme. The rule. So this part is use the provided picture to capture the part shown and determine what is the mass of the part. So this is a sketch picture command or sketch picture question. The picture is here. This is the picture, and we have to take the shape of the roof and model it on SolidWorks. And by the way, this is a method used in reverse engineering. It is pretty basic actually, but if you want to reverse engineer a bottle or so, a water bottle, you can take a picture of it and insert it on SolidWorks and make the curves of it. So we'll select a plane, front plane. We can search sketch picture, and see where is it. I have it, but we can search from tools, sketch entities. It is somewhere there in tools or insert, but I have it here, or you can search it if you don't want, if you don't know where is it located. So sketch picture, we'll add a photo. And this photo is not scaled, so the program doesn't know any length of this picture, so I have to give it a scale. In this question, he gives us a scale, which is this number 90.58 millimeters. So this is our scale. This is the scale tool. So this is the scale tool. Put it in the first line or in the first place here. So this is the start, and the finish will be on the top face of the roof. we will make sure that it is vertical, so it is not angled by the vertical sign. And very good. The scale is 90 point what? 90.58. Very good. So after we put the scale, now the picture is scaled to uh, to uh, to draw on the edges. So now we have to just draw the edges. We can revolve it because it is a revolved part. We want the center line. Just make a line from there to there and fix it. And the midpoint of it is the revolve center. Very good. I'll just make it fixed on the top. So now you'll have to draw on the lines of the picture. Any straight part, you can draw it by a line. And otherwise, you can make a spline. You can draw it by a spline. So we'll continue by spline. First one, enter. The second. You have to make sure that you are uh, taking the shape of all the edges. In this question, actually, or in this kind of questions, there will be an error margin which is quite large. In normal, it is plus or minus 1%, but in this question, because the error is much more, it could be minus or plus 3% or 4% or so. Let's capture this and add a line, make tangent, and this is spline again. Line. It's quite boring actually, but it is the only way to do so. And here we have a line, and we'll close the shape. And this is horizontal. Very good. So we've closed the contour, and we will make this solid line. Solid line. Now we will revolve. Might be an issue. Wasn't an issue. So this is the shape of the rook. Now all that is left is the cuts in the top of it. So it is a rectangle 6.5. We'll just draw on any plane. 6.5. The depth is 5.15, 6.5, and we'll make this in the midpoint of this line. Now we can extrude cut through all both directions, and we can make a circular pattern of the same feature twice. Doesn't matter. No. Very good. So last cut is this radius 14.34. Will This is the center, 14.34. This is the radius, right? Multiplied by 2. So extrude cut. And we can double click on this surface. It should work. Cut the surface. And this is the final part. Cuts, we have the rectangle cuts, and we've captured the part from the picture. Now we can add the material, ceramic porcelain. Shift M, ceramic porcelain. Now this is the final part. We can measure the mass, and this is the correct answer, 190 grams. So this is the ninth question. Still 1, 2, 3, 4, 3 questions left. Now we have a topic which is assembly modifications. So you have an assembly, and you could make modifications in the assembly as an in-context feature, or just edit the part. So this is what the question is talking about. So let's see. In this question, the part should be provided. This assembly should be provided. You will not model this assembly. So let's open it. Okay, so let's read the question. So it tells us to make the circular face with P3A, which is indicated this P3A, the circular face, which is this circular face, always tangent to the faces mentioned. These are the faces mentioned. The yellow faces, P3A, should follow all the tangent faces, which is indicated by yellow, on P1A. This is P1A. Very good. So what is the problem now? If we get into the assembly, let's see, there isn't any mates. So this, first we will make the mates. Coincident. And he tells us that these two faces are parallel. Parallel. Very good. So I can move it freely. I want to make this face tangent to all of these faces. There might be two solutions. CAM, which is not a valid solution, because CAM, mechanical CAM require a CAM path which is closed, but this is open. So we can select CAMs, and it will not select because he wants closed entity. So the other way is making it tangent, but we can't make it tangent to all the faces. We can make it tangent to just a single face, either this. Oh, this is not. We have to make it fixed or fully defined. These two faces are coincident. So it is fixed. So now we can move this. It is following the path, right? but whenever it gets into second face, it will not move it. It will not be tangent to it. The same thing if we make a tangent made from this and this, it will also not follow all the paths. So what is the solution? One of the solutions is making all of these surfaces a single surface. Let's open this part, and we can edit the part in the assembly. Either way is fine, but I will open it. So I want to make all of these surfaces a single face. Let's experiment this command, delete and patch, and see what it will do. It will not. So delete and patch fails uh, in this case. So it will not be valid. So what should we do? There is a way to do it. Let's open the sketch itself. So the different faces, or there is multiple faces because there is multiple segments in the sketch. This segment and so on. So that results in multiple faces. So a one answer for this is using the fit spline command. Fit spline makes multiple segments a spline, which results in a single segment. Uh, Spline is a single segment, and you can make any segment spline. So spline will do the job for us. Close the spline. It is not closed, it is open. We'll just select all the segments and click yes. Now we can see, if we click on it, that this is a single segment. Let's close it and see the face. It is now a single segment. Let's make it yellow. So let's get back. Now, if we make the tangent command again, let's see if it will be okay. Very good. So it behaves like the way the way we want. So what is question? Make there is a condition here, is that there is a condition, this face and this face have a dimension between them 25 millimeters. Whenever this happens, check the value of x, the value which is the dimension or the uh, space between this face and this face. And he tells us a note: the drawing doesn't represent the real position of P3A. So let's see. This is easy because we can add a mate between this face and this face, which is a distance mate, 25. And let's see from there. It is not in the same position, yes, and he tells us that it is not in the real position. So the assembly is fully defined. Now we can measure the x distance it gives us. Evaluate measure that face and this face, and the answer is 29.6 millimeters. So this is one of the ways to solve this problem. We could actually there is another way, by doing surfacing, deleting the surface and redoing it by surface commands, boundary surface or fill surface. Either one will do probably good, but this is the fastest way, by using fit spline. So let's close this, don't save. Very good. Let's see another question. Assembly in context. Sweep a hollow circle in the spline shown. Determine the mass of the pipe. So this is also a provided part. We have to open it. Ah, so there's part, second, third. They all mated together, or they are already made in the assembly. Uh, this this sign indicates that these parts are in context parts. They are made on the assembly, top-down assembly. So let's see. There is a spline that is connecting between uh, this cylinder, and this cylinder, and we want to sweep a hollow circle on the spline shown. Okay, let's get into the part. We are drawing, or we are making a part in the assembly, so we should make a new part on a plane, front plane. It is in the middle. So insert component, new part on the front plane. So we are opening a new part, right? Yes, we are in edit feature command. So we are in a new part. We can make a new part in the assembly. Front plane sketch. Where we should make this hidden, either by hidden lines or keyboard shortcut. Either one is good. So let's see. What's oh, I hid the part accidentally by pressing tab. Okay. Let's spline from from this point to this point, and we can modify the handles. It's taken in relation that isn't. Oh, yes, this is our spline. It has only 2 points, and it is indicated, or it is not indicated. I forgot to add it, but it has 2 points. Because adding 3 points or more splines, it will have a lot of dimensions and relations to constrain it and make it fully defined. So 2 points is good. And I forgot to indicate that it has only 2 points, but whatever. I will modify it later. So the first constraint is that the spline length is 990. So let's add it at relation 900. This is weird. Hmm. There is a problem in defining the spline, the handle, or the magnitude. Should work fine. Hmm. I don't really know. There is a constraint. I don't know where is it exactly that is constraining us from a certain length. It is probably in the handles, the magnitude, no, either the magnitude or the angle. So why is it black? I don't really know. It worked just fine before the session. I don't know the problem. Where is it? But let's continue constraining the spline. This is tangent. It is shown here. If you it is tangent, the spline is tangent with the axis of the cylinder, and here is also tangent, and the handle, it has a dimension of 500, the magnitude handle 500, and the only constraint left that is the length. It is defined now. Less than that, not perpendicular. It is defined. So I don't really know what was the problem, but it worked now. I didn't do anything different. So the spline should be defined. So all he wants now is sweeping a hollow circle on the spline shown, and the hollow circle dimensions is the internal feature of this part. So let's draw, make a make a plane on this point and perpendicular to spline, and sketch it. Where's the plane? And sketch on it the circle. Here's 50 and 35. 50 and 35. And we'll make it Pierce relation now. They are not concentric. These two are coincident. And this and that line are Pierce relation. This is good. Now we will do sweep, feature sweep this path on the spline. Very good. Now let's get back into, this is not tangent. It was tangent. It is tangent. It is modified now. I don't really. There's sometimes when SolidWorks glitches, I don't know the reason, or no one knows actually, but it somehow behaves like that. Control B. And okay, now, so why there's a yellow, oh, whatever. So this is the pipe. It is fully defined now. Now he wants to know the mass of the pipe. And I didn't mention the material, so we can make an arbitrary one. Add material. Let's open the part itself. Add the material from it. PVC. PVC rigid. Very good. So either from the part or the assembly, we can measure the mass of the part, which is 1288 grams. So this is for the part. It is in context feature. It is testing you if you know how to make a feature in the assembly, and how to if you know the steps and so on. So this is the 11th question. One question left, which is sketch text. Let's see. So in sketch text, there is a C that is shown in the front view, and E letter shown in side view. So this indicates us to only one command, which is combine common. So let's say letters are written using sketch text, 72 points, the height. Okay, let's get into front plane and draw a line and sketch text net. It was C, and we can use a font or points of 72. Okay, it is underward, make it upward. This is the first one. Now we can sketch, exit the sketch. We can sketch on the right plane. The same center line, and the other letter was E. This is the line we'll be texting on or writing on. E. Uh, Points 72. Oh, sounds good. So now we have to extrude boss these two. There isn't any dimensions because we're using sketch text, so it is fully defined. This is the place of the part. It doesn't matter. So let's extrude boss base. Yes, letter. And extrude boss base this letter also. Reverse direction. And we have to unmerge the results. So the trick here is using direct editing, combine, common. Common is combining the common area between two bodies or more. So let's select the first, the second, click yes. If we see from this view, it is C. If we see from this, it is E. And we can also, if we wrote a letter that is Y or so, it will shown us here a Y. So this is basically combine common. Uh, it can do intricate parts by just combining two simple parts, and this could be one of the exam questions. And that's it. If anyone has a question so far about any question or any problem that we've solved, please tell us now. This might be the end of the session unless there is some questions. Anyone has questions? Yes, Faizan? You can open your microphone or text in the comment section. Mm. For the PDF or the questions, can you please provide a recording of your lecture? I've recorded actually. I've recorded the lecture. I'll provide it. I will publish it on YouTube or so, and I will give you the link, inshallah. For the PDF, I will I will make some modifications, make it some kind of more perfect, and send it to you because I'm the one who made it, so it is not perfect. I'll just do some modifications and so and add a couple questions, and I'll send it to you as a practice for the exam and also the parts. Mm, yes. Anyone wants to ask a question? Open your microphone.
Yes, Yusuf, I'm so grateful for the wonderful presentation.
Thank you.
Actually, I'm Edwin and I'm from Uganda.
Nice to meet
So
you.
recently I did my Weldments exam. Yes, I passed, but however, there are some two questions that I left unanswered, and however much I passed, but they triggered me. I think it was using automatic key arrangement related to catalyst folders. I think it was automatic arranging of catalyst folders.
Automatic
The
what?
question it was automatic. It was automatic
Automatic.
organization of the catalyst folders.
I don't quite get it. Are you talking about a certain exam? A question that triggered you?
Yeah, yeah. Actually, it was a question that he gave me high time. It was about to organizing catalyst folders within the Weldment profiles.
Cut list folders. Is that in sheet metal or weldment?
Actually, it was in Weldments. It was in
Weldment.
Weldments.
Weldment. Cut list. What was the question? I remember that was a question like that in weldment. Uh,
Actu-
wait a second. Weldment cut list as a bill of material. Or, do you remember? We have a weldment. Let's open. Uh, There is in the one exam, yes, there is a question like that, but I don't actually remember the exact questions. I took the exam like a year and a half ago, but there was a question like that. But I don't really remember the problem. If you have any details about it, I might help you, but I can't remember now. I'll share it. Yeah.
Okay, it's fine. Actually, it was using the automatic option organize the Weldment bodies into catalyst folders, as in to organize Weldment bodies into catalyst folders.
Mm, I don't really know. I might revise my exam or revise the questions, and I continue. You're with us on the WhatsApp group, right? To
Yes, it's there, Yusuf. Actually, I'll check the question and I'll share it with you. I think I have the question as well.
mm,
I have it. I'll share it with you so that you can elaborate it on the group.
very good, very good. Faizan, yes, I'll share YouTube page. Uh, okay. Anyone else has a question? Here's here you mention a WhatsApp group. Is there a link for that? Yes, there is a link. It is not official though for SolidWorks user group, Nairobi City. It was some kind of a friendly user friendly group on WhatsApp. I can give you a link. I'll share it. And here is my YouTube channel. I've created it a couple of days ago, but I will publish inshallah the session, this session and the upcoming session. Can you can you give us Charleston the WhatsApp link group? I can't really get it.
Okay, I've sent it on the chat. You can check it from there.
Okay, very good. Oh, there is someone who's asking George. This is the link of the group. You can enter it. It is Any questions? Guide us on SolidWorks simulation exam. Which one? SolidWorks simulation associate or professional? For associate, it is much easier actually. If you compare it to professional, professional is I've entered the professional exam of simulation and I failed. It was so hard actually. So I'm not that professional in simulation in terms of the SolidWorks professional exam, and it has some limited resource. It doesn't have any uh, resources that is beneficial about the SolidWorks professional. It only has a course link uh, on Drive course link Solid Professor, and this is the only resource for it, and uh, it is not good enough for the exam. About SolidWorks Associate in simulation, I can give you some resources. Uh, join the WhatsApp group link, and I will share you with you some resources of the Associate. SolidWorks Accruity program. Yes, I've heard of it. I actually joined the competition a year ago, but I withdrawed. I was busy doing some other things, but I will rejoin the competition again in this year. It is international. I believe it is open to all the world, all the countries in the world this year. So it is a good opportunity for you all. You can join. You can join this competition, which machines send in the comments. Recruiting Global 2025. How many members can join this? If you're talking about the WhatsApp group, it is probably limitless or 1,000 member. If you're talking about the competition, the team has four members, and that's it. Mm. Community members with mentor total. Yes, the team in Accruity has four students, undergraduates, and one mentor. So in total, it's five. Actually, four is working on the project, and the mentor doesn't work with them. He's just monitoring them or giving advices and so on. And you can see all the details are on the link you've sent. The details are all provided, including the themes, the competition deadlines, and so on. There is also opportunity for SolidWorks, uh, SolidWorks sponsorship program. Any team who applies for the competition will take a 1 year SolidWorks license for free or so. I don't even. Oh, yes. I don't really. Edwin, if you're still here, uh, write the comment of George. He might help you. I don't actually remember the question itself. How to get SolidWorks exams coupons? There are multiple ways actually. The first is following SolidWorks official channel or SolidWorks official website, LinkedIn or YouTube channel, 3D Experience Education on LinkedIn. Both of them, yeah, frequently, twice a year or 3 times a year, they provide free coupons, free exam vouchers. You can also follow SolidWorks user groups like Nairobi City or any group. There is in India, there is in Sudan, Sonar SolidWorks user group, there is Alexandria SolidWorks user group. All of them, a couple a year, or one chance a year, they can provide exam vouchers. There is also Islamabad SolidWorks user group. So there is multiple opportunities happen in the year, either for students, if you have uh, if you have a student email, or for everyone it was open. So all you have to do is just following all the channels or all the websites that is announces for this opportunities. How can we apply for how can we apply for career in News Swag officially for any country? Charleston would help you with this. He created the SolidWorks user group in Nairobi City, so he will absolutely have more information compared to me.
Or put it in the comments. You can check the link on the comment actually. Just put it there. It will
Mm,
outline everything. So I can apply for a group and be a leader as well.
yeah. Uh, Very good. Any other questions? Mm, so
Well, I do have one.
yes, yes, Sabir.
Okay, so I wanted to ask that what about the opportunities of CSWE exam vouchers? Lately, I haven't seen any event that is giving free CSWE exam vouchers.
Yes, actually for CSWE, it is the least opportunities it has for vouchers. Actually, in the last 2 years, only one opportunity that gave SolidWorks expert certification for free. Only one opportunity in a couple of years or so. So it is quite rare. Uh, it was from a group called Sonar, SolidWorks user group. Uh, Anyone who joined a certain meeting that was Dan Wagner was there, the SolidWorks user group's leader. He gave
Yeah,
us
yeah, I
access and
joined that and got CSWE examination vouchers from that. But yeah, and unfortunately, I didn't filed up for CSWE. That was a mistake. But yeah, you're right. There are very
you were
rare
you were in that
opportunities.
meeting. Uh, so for CSWE, it is quite rare actually. You have to wait. If you don't want to pay, it is quite expensive. One fifty $150 there. If I think if my yeah.
Okay,
So
thank you.
mm, I'm recording the session. So when I finish it, I will upload it on YouTube, or uh, uh, if it has any modifications, I will modify it and upload it, and will give you the link. And I've just sent it in the comment section, I think. Yes. So you can revise the session if you want, if you intend to go to CSWE soon. That's it. Any other questions? Okay. So thanks, Charleston, for this session, for having me. It was a great opportunity to have, actually, to talk about something that has limited resources like CSWE. So I hope this session will be beneficial to anyone. And I will just provide the the PDF uh, preparation, or PDF questions. Yeah, and I hope this helps you all. Thank you for good listening.
Thanks so much. Thank you so much, Yusuf. Actually, the session has been so remarkable and so mesmerizing because I've refreshed my knowledge in weldments and okay, I've seen weldments, surfacing,
Yeah,
sketching,
it
auto
actually,
tracing.
yes, it
Actually,
was
those
more.
things I'm
Continuous
even
control.
surprised like CSWE like comprises of all of them at Ago. So it's very good to know them. So for those who have attended, at least you have gotten some ideas of how to do the advanced SolidWorks tools. For example, when it comes to surfacing, when it comes to weldments. For example, when you saw Yusuf creating the custom profile, actually that's the basis of weldments
Mm,
professional. You have to know how to make that thing. If you don't know how to make the custom profiles, then most probably you're going to fail all of it because all
it's
of it
true.
is based on custom profiling. So things like 3D sketching, you have to know that it's also in CSWP weldments. And also surfacing, I've seen you have touched about it. And I'm also glad I refreshed my skills on tracing and such. And it has been a great session. And I hope for everyone who attended, you also gained so much from the session itself.
Yeah.
And then for those who are asking for CSWA, I'm not very sure about this but for those who are in Egypt, I think you're going to get it. I saw on Ahmed's post, Ahmed, the community SWUG leader, the overall SWUG leader for Africa, he said there's a session, like there's a SWUG tour that will be happening in Egypt from 4th of May to 17th of May, and they'll be offering I don't know, $3,000 worth of certification, but it will include a CSWE. So maybe you can check his page.
Oh,
And if you're not in Egypt, I hope they may extend it to other people who will be attending, maybe virtually or via any other means. No, I don't know, but I just hope so. He said he may consider it if people can attend virtually to get the certifications. But for those who are in Egypt, take chance because he'll be touring. I think most of the Egyptian universities, yeah, so take chance and do your
yeah.
CSWE if you'll manage to.
It will
Yeah,
happen in five cities in Egypt, yes. And I hope that it will be online,
I hope so as
like
well.
other meetings. Alexandria SWUG also it has some meetings that was offline and online, and both of them has the opportunity to get a voucher. So I hope so that happens, and I hope your your information about the CSWE voucher also is correct, because
Yes, yes, yes.
a lot of people here will be happy for that.
Yes, yes. Actually, I saw it on Ahmed's page, so I'm very, very sure about it. So we are very optimistic. Hopefully,
Mhm.
he'll take in online. People attend online like me. I myself, I'll also attend online if possible. So who else has a question before we close? And then I hope you have attended like for those who have not joined the group, you can join the group.
The
That's where we interact, all of us, and we grow. It's not a SWAG group per se, it's just a general CAD group for
mm,
CAD enthusiasts, and people will be there overall. Yes. So who has a question or who needs clarification on anything before we adjourn the meeting? Because it's already 6 p.m. over here.
mm, it
Who has a
is.
question?
We're on time, 6 p.m.
Yes, yes. Then that's great. I'm grateful for all of you who attended. You can check on the recordings for those who came a bit late. And if you have any other topic you feel we should discuss or you love to see a speaker discuss about it, then you can inform me earlier so that we organize and set everything in order. Sure,
Sure.
sure. All right. Cheers and have a wonderful evening to you all. Thank you so much, Yusuf, and to many more sessions with you. If you get
Sure.
any other ideas which you feel you can share with us, then just feel free to book a session and all shall be well altogether. Thank you for
Thanks.
being our speaker
Thank.
today.
Thanks for having me, Charleston.
Sure. To everyone who attended, cheers and see you next time. Have a wonderful evening.
Goodbye, everyone.
Bye. You can leave at your own pleasure.